Welcome to the Knowledge Bank, where we simplify complex environmental topics into clear, actionable insights. Today, we're diving into a critical air quality parameter that often goes unnoticed yet plays a significant role in both indoor and outdoor environments. Total Volatile Organic Compounds, or TVOCs. Let's begin by understanding what TVOCs really are and why they matter more than we think. Ever walked into a freshly painted room and noticed a strong smell? Or unboxed new furniture with a distinct odor? What you're experiencing is the presence of volatile organic compounds, or VOCs, chemicals that easily evaporate into the air at room temperature. They are present in everyday materials such as paints, cleaning agents, adhesives, furniture, air fresheners, and more. But with thousands of VOCs in existence, tracking each one individually isn't practical. That's why we measure TVOCs, the total concentration of all volatile organic compounds present in the air. Some VOCs, like benzene and formaldehyde, are known to be harmful, while others may have minimal impact. However, when present in high concentrations or over prolonged exposure, TVOCs can lead to headaches, dizziness, and respiratory discomfort. And considering that we spend nearly 90% of our time indoors, understanding and monitoring TVOCs becomes not just important but essential. From vehicle emissions releasing ethane to trees emitting isoprene, VOCs are part of our everyday environment. With over 10,000 types identified, their cumulative impact is what truly matters. Which brings us to the next question: where do all these VOCs come from? In reality, VOCs are everywhere and often unavoidable. Indoors, common sources include paints, varnishes, cleaning products, cosmetics, adhesives, disinfectants, and even emissions from building materials. Interestingly, even human presence contributes through natural bioeffluents. Outdoors, VOCs originate from both natural systems and human activity. Forests, oceans, wetlands, and even volcanic activity release VOCs naturally. However, the dominant contributions come from human-driven sources such as vehicle emissions, fossil fuel combustion, industrial processes, tobacco smoke, and petroleum refining. Whether it's within enclosed indoor spaces or across urban environments, VOCs continuously influence the air we breathe. But what does this actually mean for our health and the environment? The impact of TVOCs is directly linked to exposure levels and duration. In the short term, exposure can lead to eye, nose, and throat irritation, along with headaches, dizziness, nausea, and allergic reactions. Even brief exposure can trigger respiratory discomfort or skin sensitivity. However, the long-term effects are far more serious. Certain VOCs, such as benzene and formaldehyde, are classified as human carcinogens. Prolonged exposure has been associated with chronic respiratory conditions, organ damage, nervous system disorders, and increased cancer risk. And the impact extends beyond human health. In the atmosphere, VOCs react with nitrogen oxides in the presence of sunlight, leading to the formation of ground-level ozone, smog, and secondary particulate matter, all of which degrade air quality and reduce visibility. Even what is commonly perceived as a harmless new car smell is, in reality, a mixture of VOCs contributing to indoor air pollution. So, while VOCs may not always be visible, their impact is both immediate and far-reaching. This makes it critical not just to understand them but to actively control exposure. In fact, indoor air can often be up to 5 times more polluted than outdoor air. And with most of our time spent indoors, managing TVOCs becomes a priority. Here are a few practical steps. Ensure regular ventilation by allowing fresh air circulation. Maintain controlled temperature and humidity levels as VOC emissions increase with heat. Properly store and dispose of chemicals like paints and solvents. Regularly check for leaks in stored substances. Avoid indoor combustion activities such as smoking or fuel burning. During renovations, ensure adequate airflow and minimize direct exposure. For outdoor environments, limit exposure in high traffic or industrial zones. Use low VOC materials in construction and maintenance. Support and adopt cleaner mobility solutions like electric vehicles. Encourage stricter emission regulations and compliance. While these steps help reduce exposure, effective control begins with accurate understanding. Which brings us to a critical question: how do we measure TVOCs? TVOCs may not be visible, but they can be measured, tracked, and managed with the right technologies. There are 3 primary methods used: photoionization detection, PID. This method uses high energy UV light to ionize VOC molecules. The resulting electrical current is directly proportional to VOC concentration, enabling fast and reliable detection. Flame ionization detection, FID. Here, VOCs are ionized using a hydrogen flame. The ions generated produce a measurable signal that reflects concentration levels, making it highly effective for hydrocarbon detection. Semiconductor sensors. These sensors detect VOCs through reactions on a metal oxide surface, where changes in electrical resistance indicate concentration levels. While effective, they typically consume more power compared to PID and FID. In today's environments, where air quality can change rapidly, real-time monitoring becomes critical. Using advanced sensing technologies, modern air quality systems are capable of continuously tracking TVOCs with high accuracy, even at low concentrations. Because when you have reliable data, you can move from observation to action, quickly, confidently, and effectively. TVOCs are all around us, from the materials we use indoors to emissions in our outdoor environment. While some may be relatively harmless, prolonged exposure to elevated levels can significantly impact both human health and environmental quality. Understanding their sources, recognizing their effects, taking preventive measures, and most importantly, monitoring them effectively allows us to move from awareness to control. Because the air we measure is the air we can improve. We hope this gave you a deeper understanding of Total Volatile Organic Compound. If you have questions or would like to explore further, we're always here to help. Stay informed, stay safe, and keep breathing clean.